Hello everybody. It is Mike Levin on Monday, October 12th, 2021. And yesterday was my 3-year anniversary. My wife was a little bit sick, so we didn't go out so much, but we ordered stuff in and we did a little cooking, a little celebrating, and in fact, my kid was with us, and I'm only just coming from dropping her back off. It was a midday drop-off, and I ended up shuffling around some deliverables, getting things in time, waking up early, making sure my tooling was ready. I had an early morning meeting, and between that early morning meeting and then the next meeting later in the day, I had to have that deliverable in hand so that we could talk about it and take things to the next step. And happily, I was able to do that. I had a little ironing out to do, but it was only because of the neglecting of using the correct variable name in one location. So I fixed that, regenerated something, and no work was lost, and everything looked wonderful. One of my really higher quality recently deliverables, because my tooling is so much tighter and the process is so much more tight and elegant. I really can't wait to push out some of these things again on the Pipulate project and make a handful of them public, because things have really reached a very zen state with Python and SEO. Things have reached a zen site with SEO in the Python world because of Jupyter notebooks, Jupyter Labs in particular, which I'm using, plus NBDev, which allows you to use Jupyter notebooks, which have lots of built-in documentation, automatic presentation making. It's really a wonderful environment to both document what you're doing, explore. I say both, it's more than both. It's a wonderful environment to document what you're doing, to explore and experiment, but then from which to extract your really solid reusable pieces, which you can drop into certain cells that are going to get exported by NBDev. So it's a framework, and lo and behold, another framework with its own conventions. So there was once a time when I was enamored with frameworks, and I found the opinions and conventions, the conventional opinions of the framework makers, people like DHH, who did Ruby on Rails, as delightful and something to sort of revel in, learn a new template system, learn a new, CRUD configuration model. But I'm too old for that stuff now. There's not enough time in my life left to just keep stacking on the next wafer-thin framework. But NBDev is worth it because it's a game changer, and the conventions are really not so much more on top of what you have to do anyway, nor are they so much different than what you have to do for the Python packaging index. So that gives that magical coming together of multiple Venn diagrams, one of them being the way you work in a notebook, this delightful live code way of working, which includes built-in documentation. So that's just the whole notebook shebang as one of the circles on the Venn diagram. Another circle on the Venn diagram is the ability to export packages. And that sounds big and mysterious, but all it means is that one of your files amongst your set of files you're using should be a .py file that's organized a certain way so that it can be released on PyPy, so that other people can pip install it, and so that it has the kinds of behaviors that people expect, that certain built-in methods and properties are auto-discoverable, and learning that NBDev takes a lot of responsibility for making all your, classes and methods and properties and all that stuff auto-discoverable. It's a funny thing, that auto-discovery, what Microsoft calls IntelliSense, what a lot of other packages call auto-completion. And this is the area where things that are really made for Python shine, because it's hard, it's difficult, it takes a lot of specializing with a language like Python because it's dynamic. All those little twinkly pop-up things that tell you what you can type are a little bit more difficult than in static typed or static hinted, static variable languages, where all variable types have to be declared, of what type they are, how big they are, etc. And in those cases, you live in a very deterministic world. It's less dynamic, and things can be kind of look-aheaded, is that a word? Better. And auto-completion works better. With things like Python, you've got lists, and members are dynamic. So it's a little bit harder to do that, I'm told. I don't do really this, language translation stuff. But Jupyter Notebooks certainly does, and so do environments, basically any IDE, PyCharm, VS Code. And they do it rather well, because this is one of the places where an IDE is really called upon to shine, so that you can build up muscle memory that's dependent on these rails that the IDE provides you. So then you're dependent on that IDE for the rest of your life. And is that really any worse than someone like me being dependent on Vim or VI editors for the rest of my life? Well, yeah, maybe just a little bit, because versions of VI and Vim are always going to be there, and your muscle memory will always apply. Whereas VS Code and things like it, well, they come and go. Might not look like it today, but how long ago was it when VS Code wasn't here, and then suddenly it showed up on the scene, and it deliberately went out and stole all the thunder of everything else like it that was letting people down. Microsoft just rode into a giant void, an itch that everyone had to scratch, because Sublime was letting people down with version schisms. TextMate let everyone down ages before that over the exact same version schism stuff. It's strange. When there's a proprietary text editor, there's going to be the developer versus itself over some major version increment, where people are going to cling to the old stuff and say, oh, I'm never moving to the new stuff. I only paid for the old stuff. I won't do the upgrade. And then there's the developer trying to move ahead, trying to embrace new things, doing a version 2.0, 3.0, whatever it is. It happened with both Sublime and TextMate. Notepad++ never went through that. However, it's showing its age. It's a little bit crusty. And what else in that arena? Of course, Atom, ATOM, the open source, also Electron platform-based text editor from GitHub itself. But then Google bought GitHub and then created VS Code. So its other text editor child, such as it were, Atom, was abandoned, I think. Who would use Atom now with VS Code, right? Seriously? So, yeah. So you choose your poison, you develop your muscle memory, and be aware that that ties you to things. That is a great part of your dependency. Follow your muscle memory to understand what your dependencies are. And if you rely on things like auto-completion and IntelliSense for your typing, you wouldn't know it, you'd be lost to type without, then try and do it without it. Try and turn it off and figure it out on your own. And if you find yourself Googling and copying and pasting from Stack Overflow on every little Python problem, well, then you're not thinking Pythonically, because if you're thinking Pythonically, then you're probably thinking in Python. And when you're thinking in Python, you don't have to look everything up on Stack Exchange or Stack Overflow or, whatever these infinite versions of, question and answer sites are, spun off from the Joel Spolsky, endeavor. It's both a particular instance of a site, I forget which one, it's probably Stack Overflow, and then it's a system for creating sites like that, which I think is Stack Exchange, right? Because you exchange different stacks, I suppose. So that has really taken over the world in terms of, a practical alternative to learning to code. And it's, It's okay for a little while. But then you're going to realize one day that your best practices and patterns are themselves a dependency. Your thought process, your brain has the dependency of other people having tackled that problem before and having published questions and answers about it. Is that really a dependency you want? Just learn how to probe at things. And how do you probe at things in Python? How do you think Pythonically? How do you not rely on IntelliSense and autocomplete? Well, there's dir, type, and help, which is probably used in that order. Type might be more useful, but you probably have some idea of what type of object you're looking at. But nonetheless, maybe do type first and get its representation, its REPR, its string representation, what the developer thinks you ought to see when you look at that object type. It'll give you things like str for a string type, func for a function type, and etc. List types. Everything has a data type, basically. Even though Python doesn't encourage you to do object-oriented, particularly in your own style, it uses object-oriented in most things under the scene. So you've got a lot of factory classes, and things are stamped out instances of those factory classes. So when you're sitting on a list data type, it's an instance of the list factory class. And there's a lot of syntactical sugar in Python, so you don't have to think about that. When you're using those square brackets to define a list, or the curly brackets to define a dictionary, or the parentheses to define a tuple, you're really leaning heavily on syntactical sugar that allows you to do a very lightweight version of object-oriented design, instantiating instances of factory classes without thinking about it at all. You don't have to think about object-oriented design. And if you like that, not thinking about OO and getting the benefits of it, you take the next step up one day and start using the external. It's part of the standard library, but nonetheless, you have to, from collections, import named tuple. And that takes you the next step up in instantiating out instances of factory classes that alleviate you lots of traditional headache and grief, a lot of housekeeping, because each of these things has its own particular flavor or behavior, which covers about 30% of your use cases. So list tuples and dictionaries, 30, 60, 90, right? 90% of your common use cases are handled by those simple 3 data types or data classes in Python. The remaining 10% gets split up over like everything else, named tuples, other types of custom classes. And so, yeah, when you're at a loss for something, just throw the word type around it. Type open close parenthesis around your object, and it'll tell you what data type it is. The next thing you do is dir. You look inside of it with dir, short for directory, just like in DOS and stuff, but this gives you a directory of all your things inside of your, instance of a class, and you'll see all the dunder stuff, like the dunder inits and, length and all this stuff that is very common in Python, that, classes of particular types, they make sure they have all these base classes, like iterable and stuff. And you never use it. You rarely use this dunder init. You say that, except one of the most common patterns in Python is if dunder name equals dunder main in strings, then you provide an entry point. So right in the same breath, Python best practices says don't use the dunders, and then one of the most common patterns out there to create an entry point in case you import your package, or you run your package with the intent of actually running code in it without doing it as an import, because imports are generally silent effects with are generally silent with no side effects. So when you import a .py package, it comes in and nothing happens. In the rare instance, something happens. My Pipulate package, something happens. I force the OAuth authentication so that people don't need to know that first step, because so much in SEO requires having OAuth authentication. So I just sort of push you right over the edge on importing Pipulate. Let's do OAuth. But 99 times out of 100, when you import a package, it just silently imports. And then you need to know something about that package to use it. And that's where IntelliSense and autocomplete starts to kick in. You can dir that object name. Sometimes things are callable. One of the great sources of confusion in Python is when to use the open-close parenthesis at the end of a function name. So functions in general can be referred to without calling them, without running them. And you can do that in many cases, passing whole functions in as arguments to another function. It's a trick that's often done in the Ruby and JavaScript world because it so encourages it. But in Python, anonymous functions has this lambda keyword and is forced to be one-liners. So passing whole anonymous, non-named functions into other functions as input is not as common of a stupid programming trick in Python as you'll see in other languages. But nonetheless, if you def your function, if you give it a real definition, a real name, you can pass an instance of that function into another function as an argument on a parameter. Little known or used fact among non-advanced Python people. But I have a need for that coming up. In fact, it has a lot to do with all this concurrency work that I've been talking about. And if you want to explore a delightful little bit of arcana, let's do it. Okay, mental puzzle. One of the easiest ways to get a big speed gain today without even tapping the multi-processor capabilities of our computers is to get rid of the bottleneck of the HTTP protocol, because to make a call over the web or the internet doesn't take that much work, especially if you're sharing a session or a HTTP client between calls. If all your scaffolding of all your setup work doesn't have to be redone for each subsequent HTTP call, you can call a lot of web pages at once. And the cookie data is good too. If pages respond with the cookie data in their response for trackers or to keep you identified, if you're using the same session object for subsequent HTTP calls to that same site, it's going to use those cookie values in the response, and it's going to look just like a normal web browser. It won't look like a new web browser all the time, which is one of the things that triggers off CAPTCHAs, by the way, for all you people out there going, why do I get CAPTCHAs so quickly on my Google searches? Well, it's because they know what you're doing. They can profile you pretty easily, and you do a number of very modest things to avoid being profiled and to share your session between HTTP calls that are doing such things as Google searches, for example, would be one of the ways that one of the modest precautions you take against looking like a scraper, a SERP scraper. So, anyway, you want to get rid of the bottleneck of simultaneous HTTP calls. You don't even need the power of multi-processing. You certainly don't want to be using threads and thread lockings. Oh my God, the times I've tried to do thread and operating system oriented multitasking, why? Just why? You're either doing Nonblocking IO, which is very modest and you can achieve through packages that are async IO aware, that allow the use of the async and await keywords on them, like HTTPX and clients created from HTTPX. So my current favorite trick is to create a client from HTTPX, which seems to be the heir apparent to the request package, until the request package modernizes and it supports the async IO library and the async await keywords. Now, there's ways to monkey patch requests to allow it by using G requests. I don't like it. Mikey no likey G requests. I would much rather use the beta library, the under development library of HTTPX, and have better performance and have native async IO aware package, right? So that's what I'm doing. I'm using pip install HTTPX. That's step one. It gives you an alternative to the Kenneth Wright's request package, HTTP for humans. Very popular, highly recommended. Everyone should be using it, or its API more accurately these days, because the reasons to use the request library are gradually winding down as it doesn't adopt support for asynchronicity. The reasons to use its alternative, HTTPX, are winding up as the benefit is easier and easier to realize for schmoes like me who generally don't like concurrency, okay? So it's the easy concurrency, it's the non-blocking IO concurrency, the same kind as in JavaScript. It's not the parallel concurrency, which I talk about here and there in other videos, and we'll get to that when it's necessary. When you gotta tap your cores, we can tap your cores. But until you gotta tap your cores, all you need to do is get onto the next HTTP call, throttled by some internal housekeeping. It's a 20 at a time queue that you really don't need to know much about. You can override it in the HTTPX client, but by creating an instance of the HTTPX client, the async IO client, you have access through its API because it pops open new surface area for setting key values. I believe it might even be on the context manager. So when you create a new instance of the async IO client from HTTPX, you use with async IO client, name of request you're doing, as, and then under that as, you iterate through each member of the concurrent request and you magically have it. And you do such things as update database records or create new records based on what came back from the HTTP calls. Or more commonly, in my case, it's update existing records, because I do a first pass now on the database to create plugs containing none usually. So it's name value pairs on the SQL Server Lite database using the SQLite dict package pip install SQLite. From SQLite dict, import SQLite dict as SQL dict. Watch your capitalization on all the prior. And then what you have is the thing that you can use on a with open, I believe, or with SQL dict. It's got an implied open. So under the with SQL dict, with one context manager, you can do with async client as another handle. And then you've got this nested context manager that lets you empty out your concurrent request promise using the await keyword. Down here, you move the await on the list processing down to the context manager line for the async client. I know it sounds like gobbledygook and programming doesn't come across well in audio, as the Talk Python to Me podcast keeps pointing out over and over. But I think once you've reduced the API to simple enough, you can talk through your code because it is simple and your keywords are all simple and it is what it says and it does what you say to do. And that's the kind of simplicity in your APIs that you're seeking to achieve, even when making a bunch of calls to an API, populating a local raw data store, and then iterating through that to do various extractions and transforms. That's the recurring trick of it all. You get your cache for free. You get to re-explore transforms against your raw data, which is an art form in itself that taps such other wonderful things as list comprehensions. And anytime you have list comprehensions, you have parallelizability for the most part. And so that's where you get your parallelizableness if you want. If your job is so big that you have to farm it out over multiple cores on your own machine, or multiple, what would you call it out there on the web? Virtual machines? I don't know. People using it these days, I think there's Sparks. There's, you're farming it out to a abstract notion of a processor that you can just grab from a remote pool, like Amazon Lambda is one of them, and they all have it serverless. They're calling it serverless, right? You can map reduce anything in a list comprehension over the serverless services provided by these days. It's Azure, Amazon, and Google, right? I got the three big cloud ones, and of course there's things like Linode and stuff out there, and you can use those. However, for simplicity's sake, by the way, it's usually by layering in the Dask package. The Dask package is your key to parallelizing a list comprehension based map reducible task over multiple cores locally or multiple remote resources, right? I don't do that much, but I'm ready. It's under the category of scale when you need to. There's a few key API points where you got to be ready to rewire it to the cloud. The list reductions of your data transforms and map reduce like processes are one such location. Highly, scalable. Just throw more cores at it. I guess that would be vertically scalable, but because your machine, your one instance of your machine that's asked to do the work, just magically looks like it has more capacity. So there's vertical scaling and there's horizontal scaling. Vertical scaling gives whatever you're using, a single unit of whatever you're using, seemingly ungodly more capability. And that would be by map reducing, data transforms within it, right? That's one form. The other form of scaling is horizontal scaling, where you instantiate out more complete instances of your unit of computing, your server instance, your Jupyter Notebook instance. It's like spawning off more Jupyter Notebooks. And horizontal scaling is for the DevOps of the world. It uses other kinds of techs in the picture, things like, Ansible, I think, comes to mind. It's all kinds of deployment techs, taking heartbeats, doing health checks of your network and stuff. I don't do that kind of stuff too much either. Once again, the concept of the 80-20 rule keeps reasserting itself. Rarely is my data so large that I have to farm it out to the cloud. More so, I'd use the cloud to data warehouse smaller jobs that I do recently. So whenever you do a job locally, it ends up usually in a SQLite database locally. Good, solid, generic, good, solid, generic, SQLite databases. And that's where I'm going to wrap it up now, because I got some questions coming in over text, and I think that covered it pretty well. I'll pick it up again here where I left off. Deliverables are becoming as brief and breezy as I was hoping, and can't wait to show you a bit more about it. Thanks. Talk to you later.